Good morning, students. In the last lab class, we have discussed about the data transfer instructions. We have discussed about the data transfer instructions. We have seen move external, move code memory access, and push pop. Finally, we have dealt with the exchange instructions. And we have done a simple program how to access your register banks, and then how to move data inside your memory. And this class I am going to discuss about the arithmetic instructions, and later we are going to do program related to arithmetic instructions. So arithmetic instructions, we have number 1 is increment, number 2 is decrement, number 3 is addition, add or add with carry, number 4 is subtraction, number 5 is multiplication, 6 is division, 7 is DAA, decimal adjust accumulate. Okay, increment and decrement, the general format of increment and decrement instructions are for increment, we have increment A, increment any register, increment the data in a particular address, increment the data as pointed out by the data pointer. All these instructions increment the data by 1. Whereas similarly your decrement instructions will be decrement A, decrement RR, decrement address, and then decrement at the rate of RP. And one more instructions we have increment DPTR, meaning the whatever this is a DPTR register. It's a 16-bit register. This is going to point out any external memory. Whatever data that this memory is pointing, that data you need to increment by 1. That is the meaning. Okay. And similarly, add instructions, the general format is add. So A comma hash n and immediate data, add A comma RR, add A comma ADD, add A comma at the rate of RP. These are the different formats, and keep in mind this is immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, 4 type of addressing mode. And coming to your add with carry type of instructions, you need to include the carry for some repetitive addition operation. So in that case, ADC, add with the carry, that is a meaning. A comma, again we have 4 different types of addressing modes here to add CA by N address, and add carry a data pointer, add carry a register simply. Okay, This is regarding your addition. Coming to your subtraction, I'll come ahead here. The subtraction SUBB, okay, A comma ashen, SUBB A comma RR, SUBB A comma address, SUBB A comma at the rate of RP. These are the instructions. As like add with carry, there is no subtract with borrow instructions. We have only subtract instructions. Okay. And then multiplication and division. We have for multiplication, we have mul A comma B. Only these two registers can be used for multiplications. So multiply A and B. The result, so if you multiply 8-bit and 8-bit, and you will be getting 16-bit as a result. The lower order byte, you place it in A, and higher order byte, this is how your result will be stored, will be in B. Okay, will be in B. One thing you need to remember is about the overflow flag. Okay, about the overflow flag. Then we have division instructions. Okay, we have division instruction. Divide AB. Okay, we will see how to use these instructions one by one. So addition, we are going to do 8-bit addition first. Okay, adding two numbers. These two numbers can be a signed number or unsigned number. Okay, this two number can be a signed number or a unsigned number. And for signed number, these 8051, the 8051 will do 8-bit addition or subtraction, 8-bit manipulation. So this signed number, so signed number, usually the 7th bit, meaning the most significant bit, is used for representing the sign. Okay, so of the 8-bit, 0 0 0 0 0 0 0 1. Okay, the most significant bit is used for representing the sign. That will be 1 for sign number. So this is nothing but this is equivalent to minus 128 decimal. And for and how it can extend, how you can extend the range. This is 0, all 1. Okay, in sign number, a single byte number can vary from 1 followed by all 0, which is minus 128, till 0 followed by all 1, which is nothing but plus 127, decimal. Okay, which is nothing but 127 decimal. So if MSB is 1, okay, that represents a negative sign. If it is 0, that represents a positive sign. Okay, all the negative numbers will not be in its true form, but they will be in 2's complement form. Okay, when doing a signed arithmetic, we should know how the largest number is to be. That is, how many bytes are needed for each number. Okay, how many bytes are needed for each number. So in all your arithmetic instructions, we will be dealing with your program status word register, which is nothing but your 8-bit register. So keep in mind, in an 8-bit microcontroller, the number will be ranging from minus 128 decimal to plus 127 decimal. This is the maximum range that you can perform the operation on numbers. The result should be within this range. Okay. So we need to deal about the program status word register. Okay. So the program status word register is an 8-bit register used for representing the status of the program. Okay, status of the program. Okay. So I am drawing the program status word register, which is a 8-bit register. The most significant bit represents your carry. This is your auxiliary carry. This is user defined bit. You have two register select bit, namely RS0 and RS1, and then one overflow flag, and then this is also reserved for future use, and this will be your parity. Okay, in microcontroller 8051, parity will be 1 for odd parity. Okay, parity bit will be 1 for odd parity. Okay, we will do addition of two 8-bit numbers. I said about addition of two 8-bit numbers. So let us add two numbers. Let me deal with the unsigned addition. Keep in mind, for unsigned number, if there is an overflag, carry flag will be set to 1. Okay, signed numbers can be added in two ways. Either it can be added addition of like sign numbers or addition of unlike sign numbers. You have two different types of sign number addition. First we will deal with unsigned addition. Let me add 95 decimal with 189 decimal, whose equivalent is 54H and BDH, and its equivalent binary equivalent is 0101 all 41 for 5FH, and for BD is 1011 and 10 sorry, 110 1101. Okay, 1101. So if we add these two number, what we will be having? 1 plus 1, it is 0 0, followed by 111 000. We have an excess carry. Okay, so this equivalent is, this is 1, this is C. Okay, this is 1, this is C in terms of hexadecimal. So we have a carry of 1. We have a carry of 1. So when I add this 110 10 again 01, so again 1101, 111 1 and 1, 111 1 and 1. Okay, and then 111, this is 1, this is 0, this is 1 again, this is 0, this is 1 again, this is 0, and you have a carry 1. This is how you will be having. Okay, so this is 1CH, and whose equivalent in decimal is, if I add these two, what is its equivalent decimal number? 284 decimal. 284 decimal. Okay, so we are adding two numbers now. We know the result. We have 1C and we have a carry of 1, meaning we have a 9th bit 1. So this is the program status word register. So as I said already, the result will be reflected in the program status word register. So if I am adding these two, look here, we have already discussed, we have, whenever we have a carry from the lower nibble in the sense 4-bit, from this lower nibble to the higher nibble, there is a carry, then your auxiliary carry will be set to 1. So if I look here, there is an auxiliary carry that is being generated from the 3rd bit to the 4th bit, because bit starts from 0 1 2 3. From this 3rd bit there is a carry from the to the 4th bit. So the auxiliary carry flag will be set to 1. The auxiliary carry flag will be 1. And now if I have a carry, meaning if I have a 9th bit generated as a result of the arithmetic instruction, so if there is a 9th bit that is being there, so if there is a 9th bit, again your carry flag will be set to 1. So your carry flag is 1, auxiliary flag is 1, and this is a bit reserved for future use that we are not going to use, so that is 0. By default we are going to select the register bank for doing the operation, so 0 0. And overflow flag, when your overflow flag will be set to 1, listen clearly, when there is a carry out from the bit C7 to C8, okay, from the bit number 7 to bit number 8. Similarly, when there is a carry out from bit number 6 to 7, okay, so this is 0 1 2 3 4 5 6. If there is a carry from bit position 6 to 7, there is a carry. See, this grey color and all is represents a carry. And if there is a carry from bit 7 to bit 8, that is nothing but your carry flag. That is how your carry flag is set to 1, because you have a 9th bit out of your addition here. So your C7, if there is, I repeat, if there is a carry out from bit 7 to 8, and if there is a carry out from bit 6 to 7, okay, so those two carry values you XOR, C7 and C6 you XOR it. If the XOR value is 0, your overflow flag is 0. Now you have carry from C7 to C8 as well as from C6 to C7. So both are 1. And we know XOR gate is nothing but for dissimilar inputs only you will be having 1, but we have both 1, both are similar inputs. So your overflow flag will be set to 0. So overflow flag is 0, and this is also reserved for future use, that will also be 0. And what is your parity flag? I said now your parity flag will be set to 1 for odd parity in case of 8051. Okay. So look into the result. How many number of ones that this result is having? We have 3 number of ones. So this is odd number. So your parity flag will be set to 1. So as a result of this addition, we will be having 1100 and 0001 in the program status word, which is nothing but C1. And after adding, we should have 1C in the whatever the destination, or the result will be stored as 1C, should be stored as 1C after doing the program. Okay, and you have a carry. So I'll just write, this is nothing but I have moved 64 hexadecimal because we know that the equivalent value is 64 hexadecimal. Oh, I'm sorry. We are going to move 5F and BD. Okay. We are going to move 5F and BD. So we are going to move 5F to A register. I am going to move 5F and BD. So I said already, characters it can't understand, your compiler can't understand. You need to tell that it's a number. So it should be preceded by 0 BD. Add A comma B. Okay, add A comma B. Keep in mind this is immediate addressing mode, register addressing mode, and then I am adding. So let me debug this. Okay, what result I should have in the accumulator? 1C, because here add A comma B, A plus B, and the result should be stored in A. Okay, so see, the accumulator is having 1C. Okay, what we said here, the program status should have C1. See, the program status word is having C1. If I need to expand it, I can see this. This is 1100C. I have to look it from the bottom. So 1100C and 0 followed by 0001 is 1. Okay. So this is your addition of two unsigned numbers. Addition of two unsigned numbers. And see, here I have a carry. Am I right? Here I have a carry. If I need to include that carry also in this sum. Okay. So what is this number? If I have added two numbers, the result is 1C and 1. The result is 1C and 1. I have a carry. If I need to add one more number with 1C, keep in mind I need to add one more number with 1C. So I need to add what will be the third number? Shall I add 03? 1C is nothing but 0001 and 1100. Let me add 2 with this, 0110 0001 plus this carry also I need to add, plus this carry also is this one. That is logically right? So 1 plus 1 0 1 1 1 0 1. This is 1 1 1 0 0. it should be 33H should be the result, right? 33H should be the result. Let's check whether it is coming or not. Okay. So add A comma B. So now I need to include the carry also. Keep in mind the result is having the result is 1C. There is a carry, so I need to include the carry also for avoiding the error. So add with carry A comma. I'm giving an immediate number. Okay. What number I have given in the example? I have given 1C. I have added with 1 5. Am I right? I have added with 1 5. Let me add 1C. Sorry. Add C. Accumulator comma hash 1 5. No, 110 is 5 or 6. 111 is 7. So it should be add with 1 6H. Shall I add? Look at the result. Your accumulator is 33. That's what I said. Your carry is also added. Okay. See here. Your carry is also added. After adding the carry only, the result is 33. So you are getting the result here as 33. Okay. Is it clear? So now we have done with add addition of 8-bit number and adding with carry of 2 8-bit number, that 2 signed numbers. Okay. Now let me go ahead with unsigned numbers. Okay. Unsigned addition. Okay. Unsigned addition. So signed addition. I'm sorry. Let me go with signed addition. So the signed addition, either you can add 2 like numbers or you can add 2 unlike numbers. Unlike number is about the sign. Either you can add 2 minus numbers or 2 plus numbers, or plus and minus number likewise. And keep in mind whether you are adding unlike number or like number, the range, the result should be in the range of minus 128 decimal to plus 127 decimal. Only then the sign of the result will always be right. Okay. If unlike number is added, the result won't go beyond 188 to 127. In this range, if unlike number is added, the result won't be greater than this range. The result won't be greater than this range. Whereas if like numbers were added, you may have a possibility of going out of this range. Then it's an erroneous result. You need to correct the result. Okay, then it is because in the 8-bit processor or a controller, the range should be only of this minus 128 to plus 127 decimal. Okay. So for example, if I am adding 2 numbers, namely 100 decimal and 50 decimal. So the result is 150 decimal. So in the positive side, if you look this and this, okay, it has went ahead of 127. It is out of this range. This is out of the range. Okay. So how much it is excess? What I should do? I need to subtract 150 minus in this positive range 127. Sorry, 127. You will be having 23. You will be having 23. This range minus 128 to plus 127 includes 0 also. That is minus 128, minus 127, 126. You go on and on from 0 till 0 and 1, 2, 3 up to plus 127. That is the range. Okay. I can even say if I need to include this 128, let me see, 150 minus 128 will be 22. Okay, will be 22. So if I add these two numbers in binary form, and whose equivalent, this is 64 and this is 32H, and we'll be having 96H. We don't have a carry. 100 is nothing but 64H. I am writing 110, and then 4 is 0140, and 32 is 0011, and 2 is 0010. Okay, so when you add these two, and this is 0, you won't be having a carry. This is 1001, 0110. Okay, 0110. So I need to, let me subtract 150 decimal with this range first. Okay, minus 128, I will be having 22. Okay, this is 96H. If you add this value is 96H. 1001, 0110 is 96H. Okay, and we are doing signed addition. So what is the most significant bit represents your sign? This represents your sign. So if I ignore this result, okay, if I ignore this sign, I should not say result, ignore the sign bit, it will be if I ignore the sign bit, it will be 0001 and 0110, whose equivalent is 22 decimal. That is what we are getting. We are ahead of this range. Okay, that's what we are getting. The magnitude is seen to be plus 22 decimal, and this will be the correct answer. Okay, so we need to check, or we have to check that some way for accounting this 128 decimal plus 128 decimal, which is unfortunately larger than a single byte that it can hold. Okay, so when you see this, there is no carry bit. Your carry flag is 0. Here there is no carry, this is 0. And similarly, you check that do you have a carry from 6th bit to, there is carry flag is 0 in the sense there is no carry from 7th bit to 8th bit. Okay, and there is a carry from your 6th bit, we need to check the overflow flag. So I need to check whether there is a carry flag from 6 to 7 2. If you add this, this is 4 bit, 0, 1, 2, 3, 4, 5, 6, 6 to 7, there is a carry. Check. 0 1 is 1, 1 1 is 0 and there is 1, 1 1 is 0 and there is 1. Yeah, there is a carry from 6th bit to 7th bit. So there is a carry, okay, from 6th bit to 7th bit. Okay, so whenever you have an overflow flag, how will be your overflow flag? How will you assume your overflow flag? So these two you need to, when there is a carry from 6th bit, 7th bit to 8th bit and 6th bit to 7th bit, both the bits you need to XOR, meaning C7 XOR with C6. You have a carry? No, from 7th to 8th, and you have a carry from C6? Yes. If you need XOR, if you use XOR, what will be the result? This will be 1, which is nothing but your overflow flag. So now your carry flag is 1, your overflow flag is 1. Sorry, carry flag is 0 and your overflow flag is 1. When there is a carry, okay, when there is a overflow, when there is a overflow, to get the correct result, what the user has to do is, when there is an overflow, complement the sign. What is sign? Which bit is the signed bit in the sign number? The most significant bit, which is nothing but the C7th bit is your sign bit. Only if you complement the result or complement your C7th bit, you will be getting the correct result. Otherwise, you will be getting an erroneous result. Okay. So I repeat, 150 is the actual number that you subtracted from this extreme end. So we'll be getting 22 decimal. That will be your excess data. Okay, excess thing. But equivalently, what you will be getting is, what result you will be getting is, so plus 27 plus 127, what answer you will be getting is, since your sign bit is a sign number, minus 128, actual result should be 22, but what is the answer you will be getting is minus 106 decimal. What is this minus 106 decimal? That is nothing but your MSB is 11001 0110. This is your 106 decimal, equivalent value of 106 minus 106 decimal. This value only you will be getting, which is whose equivalent is 96H. But what you should get? You should get only 22 decimal. So to correct from this 96H to 26 decimal, okay, we need to accompany the program. What program? Check for the overflow flag. If the overflow flag is set to 1, complement this sign and take the result. That will be your correct result. Complementing in the sense, this will be 0 0 0, sorry 0 0 1 0 1 1 0, whose equivalent is 1 and 6. Okay, this is your sign number addition. Say, look here, I am neglecting this result. Move a comma, what is this? 100 decimal equivalent is 64, right? 64 and 32. 64 32. Either write the program as for complementing the most significant bit and take out the result, or from the result the user has to do that complementing your the sign and all, sign bit and all, and you can take out the result. So you will be getting only the erroneous result as I discussed, which is nothing but your 96. Okay. And PSW is showing to be 04. Let us check your PSW. Shall I take this? Yeah. PSW, there is no carry, but there is an overflow, and there is no auxiliary carry, meaning from lower nibble to upper nibble, and the result is also having even number of ones. Your parity is also 0, right? Yeah, your parity is all 04 is your result. So let me check. I'll come ahead with this. I'll use a different color, black. Is there is an auxiliary carry? There is no parity. Oh my goodness. But there is an overflow. So there is an overflow, and this is also 0, 0, 0. There is a carry in the result. There is no carry. There is no carry. There is no carry. And similarly, there is no auxiliary carry too. So there is no carry. There is no auxiliary carry. So this is 0, 0, 0, 0 is 0. 0, 1, 0, 0 is 4. So your PSW is right according to the manipulation. Now from the data bit, you need to check whether your overflow flag is set to 1. Yes, your overflow flag is 1. So what you need to do in this 96, complement your most significant bit and take down the correct answer to be 22 decimal or 16H. Okay, complement your most significant, but this is regarding your like numbers, like signed numbers. You are adding plus 100 and plus 50. Similarly, you can add these two digits and tell me the correct answer. This is for your work. So add minus 70 decimal with minus 80 decimal. Check out for the answer. Okay. So when you are writing your record, you need to write the individual bit position of the program status word, and you need to write down the code. Okay, aim, your apparatus required is your key, and then your procedure, manual calculation like this, two single bit numbers, single byte numbers you need to add and carry out in your program status word, and you need to represent what should be your program status word, and only then you need to simulate. Okay. And then you can take minus 30 and minus 20. You can add these two also to addition. Okay. And subtraction is very easy. Two 8-bit numbers, subtraction is very easy. So SUBB A comma ASHN. This format I said SUBB, you have 4 types of addressing mode. Either it can be A comma an immediate data, A comma an address, A comma your pointer, or A comma another register. So for all the formats, it is your opcode is sub only, subtraction. Okay, there is no subtract with borrow. Okay, there is no subtract with borrow. keep in mind, in terms of addition, when an overflow flag is set, then complement the sign bit. Okay, that will help you in the like sign number, unlike sign number, or like sign number addition and subtraction. Okay. So here also you need to take care of your carry flag. So here also the general rule is, when an overflow flag is set to 1, then complement the sign bit. Okay, and the overflow flag also signals that the result will be greater. The result is greater than the range minus 128 decimal to plus 127 decimal. Okay, so use your subtraction. Subtract 100 decimal with 126 decimal. So finally I will be getting minus 1, so 26. Okay, whose equivalent is like this. You will be getting 11100110. Okay, so 64 equivalent is 64H 100 decimal and E6H 126 decimal. Result is you have a carry and you will be having E6H. Okay, so in addition, you will be seeing for overflow flag will be set when there is a carry out from C7 to C6 and C6 to C7, but whereas in subtraction there will be a carry in from C8 to C7 and C7 to C6, then your overflow flag will be set to 1. Okay, your overflow flag will be set to 1. Again there is an XOR, but instead of carry out there will be carry in. Carry in, namely from C8 to C7, and this is from C7 to C6. When there is a carry in, perform the XOR operation and change your overflow flag accordingly. So here you have a carry. Your carry flag is set to 1. Okay. There is no overflow because there is no carry in. You can perform individual operations and check. Okay, and all these manual calculations should be there in the record. Okay, multiplication is very easy. Do your subtraction with these two numbers. Use SUBB, use any of the addressing modes and complete. And coming to your multiplication, MUL A comma B. I said already your LSB of the result after performing your multiplication, that will be in A, MSB in B. How do you know that there is an MSB in B? That will also be referred by using your overflow flag. When your overflow flag is set to 1, meaning there is data, there is an MSB, and it is available in B. It is in B. That is the meaning. So, and similarly you will be having division. So perform this multiplication AB by using A will be equal to 7CH and B will be equal to FBH, and do your multiplication, check for your PSW. Okay. Similarly for your division, divide A by B. Okay, quotient will be in A will be equal to the quotient, B will be equal to the remainder, In this case, if overflow flag is 0, okay, or the overflow flag is cleared to 0 unless your B register holds 00 before division. It is A divided by B. So, if B holds 00 before division, in the sense A by B, A by 0, then only that is nothing but division by 0, then your overflow flag will be set to 1. Otherwise, your overflow flag will be 0 only. You getting me? Okay. So, your overflow flag will be set to 1 for division by 0. Overflow flag will be set to 1 for division by 0. For the division, you can take a simple number 08H A and 02H B, or 8 decimal and 2 decimal, or in decimal if you take, that will be much better, 08 decimal and 02 decimal. So, I have done perform for addition with carry. Subtraction also you can do, instead of I am doing for unsigned number, do it for signed subtraction. You have to do it for signed subtraction. I'm sorry. Okay, check for your result. 64 and 32. Okay, 64 minus 32. Okay, and you even perform in the calculator, even I am doing in the calculator. So, it's hexadecimal. 64 minus 32. Your result is 32. Okay, that is stored in A. Because A minus B, the result will be stored in A. You keep in mind, I am doing it for signed. Okay. So, your work is, what you have to do is, the program addition only, I am telling about 8-bit number for signed and unsigned. To subtraction again for signed and unsigned. I think I have given the data for addition. I have given the data. For subtraction I haven't. You take your own number. Unsigned, it's easy. Now I have done for unsigned, no, 64 minus H minus 32H. So for signed number, you take minus 32 minus 132, that is one number. 162 I can take. Both are decimal. And then plus 162 minus 22. Both are decimal. This you can do. And multiplication and division I have given the data. Okay. Division you take 0.8 decimal and 0.2 decimal. That will be easy for checking the result, taking out the result. Okay. These are the experiments you need to perform, and for each experiment you need to write down your aim, your apparatus required, your procedure, manual calculation, step by step manual calculation for these data. The manual calculation should include your PSW register also. and then do your coding program and the snapshot of your result. And your observations. This is your observation. And then inference result. So this is your for each of this. Okay, each of this. So 3 category you will be having 1, 2, 3, 4 categories. I have done only 8 bit. And next class will let us deal with 16-bit addition subtraction, and then we go ahead with the next programs and all. Okay. Thank you guys.